Hi guys, coming back to today, the identities and parametrics. So we're looking at the parametric equations today, but thinking about identities as well. And when you're looking at this question that I've got set out for us, you can see that x is equal to 2 sine t minus 1 and y equals 5 cos t plus 4. So t is the parameter that's changing, which alters the x and y. And that creates this graph. So you can see a lovely oval shape. And that's much easier to draw from parametric point of view than it is from a Cartesian point of view. So let's see how we can get to that Cartesian formula. Now, I'm going to start off thinking about how to eliminate t in both cases. Now, previously we made t the subject and then substituted one into the other. You can see here I'm going to end up with an arc sign, which if I do a cos of an arc sign, that's going to be really tricky. So let's choose a different method. Here is really the key to where I'm going. And if I said to you, name me an identity in trigonometry, you would go straight for the one that sine squared t plus cos squared t equals 1. That's where you'd head for straight away. So what I'm going to do is I'm going to try and make sine t the subject of this one and cos t the subject of that one, and then see if we can use this identity. So I'm going to say that on the first one, sine t is equal to x plus 1 divided by 2 and cos t from the second one is equal to y take 4 over 5. So if I were then to look at sine squared t plus cos squared t, I would have x plus 1 over 2 squared plus y take 4 over 5 squared equals 1. And I think there might be a temptation there to say, okay, let's square the brackets out and see where it takes us. But actually, that might not take us in the right direction, because I think it's actually okay to leave it like that. Because if you look at that, if I didn't have these bits here, you would say, well, that's a circle. And what we are going to do, what this actually is the stretching of a circle. So if we started off with x plus 1 squared plus y minus 4 squared equals 1, you would tell me that that was a circle with minus 1, 4 as the centre and a radius of 1. Now if I start with that circle and then imagine inside this squared function I'm going to divide by 2, that will stretch it a scale factor 2 in the x direction, and within the y function I'm going to divide by 5, that'll stretch it a scale factor 5 in the y direction. So it's a stretch of 5 in the y and a stretch of 2 in the x. Now for the purpose of this question, you're aiming to get to here, but if I overlay the circle and the oval here, you should see that this causes a stretch of 5 and this causes a stretch of 2, and that's bringing you back to some earlier work, which I thought it was good to overlap. But for the main point of today's lesson, we are looking at thinking about what identities can be used to eliminate the trigonometrical factor. So there's lots of identities we can use. We might use the double angle ones, we might use the cot and cosec ones, we might use the tan squared and sec squared. So there's lots to use. You need them at hand, and it's probably a good idea to have them on a sheet at the side of you whilst you're doing this. Okay, hope that's given you a good start.